Now we're going to go on to some word problems, but these are the word problems that you went over in trig before. These are your compounded interest problems. So the equation that we're going to use, if it says compounded continuously, so that's the key word, is the continuous, is going to be using the PERT formula. So it's A equals PE to the RT power, where PA is the principal, R is your rate, and your T is your time. The A is the amount of money you have in the bank. So here we're saying that we're depositing $25,000 into the bank, so that's our principal. Our rate is 8.75%. So we're going to write our 8.75% as a decimal. So we're going to move our decimal place 2 spaces to the left. So it's going to be 0.0875. And we're going to be able to find out on our 25th birthday how much money you're going to have. So you just plug this all into your calculator. The E button is your second LN button. And because remember, E is just a value. And we round it to 2 decimal places since it's talking about money. So if you left it in the bank at 8.75% interest, you'll end up with $222,822.57, which probably won't happen since your interest rates are usually 0.01. So now we're going to see, what if the bank only offered it compounded semi-annually? So semi-annually means that you're compounding interest 2 times a year. So we're going to let our n equals 2, and we're going to use a different equation. So it's the longer equation. So hopefully you've seen this before. N is the number of times you compound interest for that year. So if it was quarterly, it would be 4. If it's monthly, it'll be 12. So now we're going to see how much it is if you add interest twice a year. So we're just going to plug in the values. Our n is our 2. You're going to type in the whole thing into your calculator. You don't want to round off in the middle, otherwise your exact answer will be a little bit off. So for this one, when we round it to 2 decimals, you'll get this amount. So it is less since it's not compounded continuously, meaning every day. You're only compounded twice a year. And then the difference, you just subtract. So it's that amount more compounded continuously. It's more in the compounded continuously account. Our next word problem is about half-life. Half-life problems are usually the ones that you use for medicine. So our half-life equation is y equals a times 1/2 to the power of the time over the time of the half-life. So this whole thing here, this is your exponent of the 1/2. Your A is your initial sample, and your T is time. So for the first problem, we're going to have y equals, our sample is 90, so it's 90 times 1/2. Our time over half-life is 17.5 days, and we're going to leave it in for 6 days. So our T is 6, and our time over half-life is 17.5. Now, you can't really have double fractions, and a decimal is like a fraction. So on your calculator, you're going to change that to a regular single fraction. So 6 over 17.5 is the same as 12 over 35. So this is the equation that I would want to see. And then you're just going to type it all in and round to 2 decimal places. So this is going to be approximately 70.96. And you label it milligrams of arsenic 74. So I'm just going to tell you the answer for the second one, and hopefully you'll be able to figure out what the equation is. the answer you should get Y is approximately 0.43 milligrams of iodine when 30